Just a quick review of the concave-convex rule. Super simplified. Okay, so off to the left we have a fixed bone, and off to the right we have the movement bone. Now keep in mind, when we're talking about the concave-convex rule, we're talking about rolls and glides. Okay, so say this arm moves up. Now in general, the roll will always be with the movement arm. Okay, now because this is a concave bone moving along a convex bone, the glide will be in the same direction. Okay, now on the bottom we have a convex bone moving along a fixed concave bone. So say this bone moves up, the roll will also be up. However, the change with this one is that the glide moves in the opposite direction. When talking about the arthrokinematics in our body, always like some kind of reference, and this reference kind of points me in the right direction of the arthrokinematics of the other joints in our body. So my reference for the arthrokinematics in our body is the GH joint, and that's just because it's visually, I think it's easier to see. Now we will see a pattern as I continue that the more movements a joint has, it tends to be a convex on concave surface. So, for example, the movement is going to be our arm. So say we abduct our arm out vertically. The roll will also go with the movement. Like I said, the roll tends to usually go with the movement, but because it is a convex on concave, the glide will be in the opposite direction. So you will have a inferior glide with vertical abduction. So with the elbow, we can still reference the shoulder joint. In general, when we're talking about the elbow, it's pretty obvious that the elbow has less range of motion than the shoulder. Therefore, this kind of indicates what kind of arthrokinematics we're going to be dealing with. Now, with the humeral ulnar joint, we have a concave ulnar moving along a convex humor. So this means that everything is going to be in the same direction. So if we extend, the roll will be in the same direction and the glide will be in the same direction. Now, with the radial ulnar joint, we can still reference the shoulder. There is the proximal radial ulnar joint and the distal radial ulnar joint. Now, when we're talking about this, we know that this gives you more movement, and more movement indicates what kind of arthrokinematics we're going to be dealing with. So because there is more movement, specifically in the proximal radial ulnar joint, we can see a convex radius and then a concave ulnar portion. And the ulna is the one that's going to be stagnant while the radius moves along the ulna. So this means that everything is in the opposite direction. Now, in the distal, it's different. We have a concave radius notch with a convex ulnar notch. And this means that everything is going to be in the same direction because the radius is still moving along the ulna. Now, comparing the wrist to the shoulder and to the elbow, it's fair to say that the wrist has more movement, significantly more movement than the elbow, and it's almost similar to the shoulder. So once again, this movement kind of indicates what arthrokinematics we're going to be dealing with. Now you can see on the left image we have a convex surface on a concave surface. Therefore, any kind of movement is going to be a glide in the opposite direction. So, for example, say if we extend our wrist this way, the roll will be in the same direction, just like everything else, but the glide will be in the opposite direction. And then, of course, same thing goes for any kind of flexion. So say if we flex the wrist, the roll will go with the flex, and then the glide will be in the opposite direction.